Hello, I'm Sophie from the Biota Nutri technical team. In this video, we're going to look at improving the oxygen levels in the soil by optimizing the CEC complex when using organic fertilizers. The Cation-Exchange Capacity complex, known simply as CEC, is a property of a soil that describes its capacity to supply positively charged ion nutrients to the soil for plant uptake. The CEC is a very important soil property which influences soil structure stability, nutrient availability, soil pH, and the soil's reaction to fertilizers. To put it simply, the CEC holds nutrients and gives them to the plants. For example, clay has a high CEC, as does organic matter, which just like the clay can be very sticky. The higher amounts of organic matter and clay combine to increase the CEC complex. Soils with higher CEC values will hold more nutrients, which means less discharge into the groundwater and better nutrient uptake. As you can see, the bare surface of sandy soils is unable to hold nutrients and relies heavily on the high CEC of organic matter for the retention of nutrients in the topsoil. As a general rule, higher clay content and higher organic matter result in increased CEC levels. The CEC holds nutrients and can give it to the plants in exchange of mostly an acid that the plant emits. The bigger the CEC complex, the more nutrients will be held. This means less discharge to the groundwater. Also, it improves the soil structure and the uptake by plants. CEC is also influenced by pH, as CEC tends to increase with the pH. So besides the size of the CEC, the composition plays an important role in the oxygen and water management of the soil. Soils with a smaller CEC complex are more likely to develop deficiencies in calcium, potassium, magnesium, and other cations, while larger CEC soils are less susceptible to leaching. Soil with a CEC less than 10 centimoles of positive charge per kilogram may need careful management to be able to sustain high plant production. Soils with very small CEC will show relatively little residual effect from applications of potassium and magnesium fertilizer. This is because the potassium and magnesium ions are not buffered against leaching by adsorption on soil surfaces. Some ideas of how to manage CEC are based on balancing the ratios of calcium, magnesium, and potassium. However, for plant nutrition, the more critical factor is whether the net amount of potassium, calcium, or magnesium in the soil is adequate for plant growth. When growing with organic fertilizers, we're mainly concerned about the amount of calcium and sodium in the complex. We like to see a minimum of 70% calcium and have the sodium level at less than 1%. Next are the levels of potassium, magnesium, and iron, and the correct composition depends on the type of soil you are using. Measuring of the CEC can be done by most laboratories. We advise that the lab uses the method of measuring the CEC in an acid environment. The acid method is used because plants also use acids to make the nutrients available, so the results provide better information on what is available to the plant. It's also important to note that different laboratories use various methods to measure CEC and can return contrasting results depending on the fraction of the soil measured. Some measure CEC directly, and others calculate it as CEC by bases. Cation-Exchange Capacity is commonly measured on the fine earth fraction, soil particles less than 2 millimeters in size. In gravelly soils, the effective CEC of the soil as a whole is diluted, and if only the fine clay fraction is analyzed, reported CEC values will be higher than actual field values. Most of the time there is too much sodium in the complex. Sodium is a very small mineral, which can collect between clay particles, causing dispersion. Dispersion occurs when the clay particles swell strongly and separate from each other when wet. On drying, the soil becomes dense and without structure, and is often impermeable to water, plant roots, or even oxygen. Water will often stay on top of the ground when too much sodium is present. To remove the sodium, you need a mixture of calcium, magnesium, and potassium, with calcium being the main ingredient. Calcium is a very big mineral, which means that it collects between the clay particles, providing space for water and oxygen. It also allows space for particles of organic matter, which help provide even more oxygen. When used together, they will improve the soil structure, and the soil life becomes more active, which in turn gives you better results when growing with organic fertilizers. Growers using coir should note that it also has a CEC and will need to be buffered with a mixture of calcium, potassium, magnesium, and iron. Laboratories can measure coir with a barium chloride method. The process works the same as with soil. In general, a CEC of 12 to 14, plus minus a few points, will be an optimum productivity soil with the best potential for fertility. The optimum pH level will depend on the type of soil, but most of the time we aim for a pH between 6 to 6.2, because then the plants can take up the nutrients easier. Please note, you can have a soil with excellent physical properties, but average fertility that will far outproduce a clay soil with outstanding soil fertility. This is because of the difference between soil fertility and soil physics. So, in conclusion, we've seen that the CEC levels in your soil directly impact the uptake ability of your plants, and how soil structure is all important for success when growing with organic fertilizer. And if you have too much sodium and chloride in your water, the quality of the soil goes down over time, so good water is also important for the soil structure. I'm Sophie from the Biota Nutri technical team, saying goodbye until next time. Feel free to check out our other videos on successfully growing organic with Biota fertilizer, and please like and subscribe to see even more content on our social media channels. Thank you.